everyone, my name is Ebru. Today, I would like to introduce you to my project for the summer of HPC program. Simulation problems have become a large part of modern science. Repeating experiments and recording the result in real life would require a huge labor force. Millions of scenarios can be modeled through simulation to obtain results. One of these problems is computational fluid dynamics, as known as CFD problem. CFD is a branch of fluid mechanics that uses analysis methods to analyze and solve problems involving fluid flows. I want to help you visualize the CFD problem in my project. Imagine you have a secure box. The liquid is pouring into the box very fast, and you wonder how the fluid flows inside the box. There was already C code written to solve this problem. There are three different parameters that affect the problem. The scale factor, which has to do with the size of the problem. The Reynolds number, related to the flow property of the fluid. Tolerance, used to provide convergence control. You can see visualization of two different flows. When Reynolds number is known and Reynolds number is 2. I have written three different versions of Python to compare the speed. With using Python list and for loops, with using NumPy arrays and for loops, with using NumPy arrays and building NumPy vectorization features. For each 1000 iterations, the time that's spent by different runs. The fastest program, NumPy with vectorizations, which led us to avoid for loops. This was our expectation at first place. But we were quite surprised with other two versions. Our prediction was that the program would run faster using the NumPy library. So, we can conclude that using NumPy arrays without using efficient NumPy features, for example, vectorization, does affect performance in negative way. We also compared C and Python execution speeds. The graph shows the data generated as a result C and Python programs. According to data, efficient features of NumPy has increased performance 112 times. I have started from a serial version running on a single processor and accelerated by distributing the work over more processor cores communicated by the MPI interface. In addition, parallel approaches based on the domain decomposition. All cores calculated data and exchange necessary information due to keep the problem consistent. This is called holoswapping and it is regulated by MPI. For now, I have only run on 32 cores because I'm very lucky. The supercomputer has been out of service for maintenance all this week. I hope I can do more analysis for the report. The most important result for this project, we can say that using NumPy arrays without using efficient NumPy features like vectorization does affect performance in negative way for Python program. I hope it was an informative video for you. Thanks for listening.